Hi, how are you? Good, how are you? I think I lost my electron.
Are you sure?
Yeah, positive.
Stop. Okay, so this is an introduction to atoms. Atoms are the basic unit of matter. But what makes up matter? Elements. Correct. Elements are our building blocks of matter. And our four phases of matter are, do you remember, Ms. Moran?
I do. They are solid, liquid, gas, and plasma.
Yes. There are some scientists that came up with a theory about atoms. The first person is Dalton. Hello, I'm Dalton. He said that atoms are like smooth, hard balls that cannot be broken into smaller pieces. The next person is Thomson.
How you doing? I'm Thompson.
Thomson said that an atom has a negative charge and positive charges. Rutherford, however, added to that by saying,
Hi, I'm Rutherford.
and that atoms have a tiny center called the nucleus, and they have positive charges called protons. Here's what one depiction of an atom has looked like based off of Rutherford and Thomson. Very different from Dalton's little smooth ball here. The very last model is the Bohr model. Big deal. Okay, Niels Bohr revised the Rutherford model, and he found that electrons can only have specific amount of energy, okay, and that they moved in what are called orbitals. They move around, they have energy. Okay, those, that's one more time, Mara. These are the orbitals that contain the electrons. These little dots are the electrons. There are different parts to the atom. The atom now has three different parts. The first one are negatively charged particles called electrons. They are not happy, they are negative. The next ones are protons. They're positive and very happy like Mrs. Moran. Yay! Okay. They are found inside the nucleus, unlike the electrons, which are found outside the nucleus. The third one are the neutrons. They're neutral. They're not positive or negative, but they're also found inside of the nucleus. Okay, so outside we have the what, Mrs. Moran?
Protons.
Incorrect. Try one more time. Outside of the nucleus we have the electrons. Inside the nucleus we have the
Protons.
and the
Neutrons.
neutrons. Yes. I'm going to be quizzing you on that one. Great job. What next? Electrons, like Ms. Moran said, and protons and neutrons. Orbitals. There are different orbitals. The first one, okay, is the first energy orbital that can hold only 2 electrons. The next one is the second energy orbital, and it can hold 8 electrons. The final orbital on the outside can hold the most electrons. It can hold a total of 18. Okay, so how do atoms of different elements combine to form compounds? Mixture of electrons. They have these electrons on their outside shell called valence electrons, and they interact with each other. Okay, the highest amount of valence electrons that you can have are 8. Okay, valence electrons determine 2 different things. They determine the property of the element, okay, any of the elements we find on the periodic table, and they determine the ways that the atom can bond with other atoms. So just the way Mrs. Moran and I can bond, so can the elements, based on their valence electrons. Okay? We will be drawing electron dot diagrams, okay, based on the valence electrons of each element. Okay? If it is found in row 1 of the periodic table, which we will get into further in the class, they will only have 1 valence electron, so we will be drawing 1 dot. If it is found in row 7, it'll have 7 valence electrons, and you will draw 7 dots. For example, an electron dot diagram of water. We have 2 hydrogens. Because we know water is H2O. 2 hydrogens. Each hydrogen has 1 valence electron. So we're going to draw 1 dot for each of them. Okay, 1 electron for that hydrogen, 1 electron for this hydrogen. It is also made up of oxygen. Okay. Oxygen, however, has 6 valence electrons. So, Ms. Moreau, guess how many dots we're going to draw around oxygen?
It has 6, so 12. No? Not 6 for each?
No, there's only 1 oxygen.
So 6.
So 6. Woo! There's our 6. 1, 2, 3, 4, 5, 6. Totaling 8, and it's sharing the electrons and they're bonding together. And that is it. This is our atoms family.
This is our version of the atom family.
They're
tiny and they're teeny, much smaller than a beanie. They never can be seeny, the atom family. Together they make gases and liquids like molasses, and all the solid masses, the atom family. They're so small, they're round like a ball. They make up the air, they're everywhere, can't see them at all. Neutrons can be found where protons hang around, electrons they surround, the atom family. They're tiny and they're teeny, much smaller than a beanie. They never can be seeny, the atom family. They're so small, they're round like a ball. They make up the air, they're everywhere, can't see them at all.
Yay!
Yay!